Good morning from Washington, D.C., and also good afternoon and good evening to everyone joining us today from around the world. My name is Terry McVenis, the President and CEO of RTCA. Welcome to all of you to our Global Aviation Spectrum Summit. It is with great pleasure for us at RTCA to be teaming up with our colleagues at EUROCAE to present this international summit. And I'm joined today by Anna Van Groot, the Director General for the EUROCAE Secretariat. Welcome, Anna, and thanks for joining me.
Thank you, Terry, and a very warm welcome also from my side to all of you, wherever you are. Great to see over 400 people today turning out for the second joint event that we do with RTCA, and the first time that we do it on Spectrum, and it seems quite timely to do it. This topic has been with us for the last, year, 18 months, quite intensely, so it's only right that we finish off this year by having an event on it. While the impact of the widespread 5G deployment is a bit less hot topic in Europe compared to the US, it is still a very serious one, and we're taking this very seriously together with RTCA. Radio spectrum is a highly sought after, scarce resource, with rival spectrum users posing a growing risk of interference, and we've seen some of those discussions coming up those last 18 months or so. Aviation must act now to improve how we use our spectrum to avoid costly problems in the years ahead. And we have to really argue for a coordinated effort to modernize aviation, communication, navigation, and surveillance systems, and prevent the channel saturation that will make it difficult to transition to more modern, more capable, and more innovative systems. But really, we, EUROCAE, RTCA, as standardizers, we have to focus on what can we do, what do we have to do, what we can contribute, facilitate to show that aviation is a good guardian of the spectrum we have, how we can facilitate collaboration, how we can collaborate with our sister industries. So I'm really looking forward to two very interesting days of discussions, but over to Terry to get us started for the conference. Thank you.
Well, thanks, Anna. Yeah, I'm really excited too. I think over the next couple of days, we're going to be bringing some experts together from both industry and from government to explore some of those aviation standards and some of the safety methodologies that are going to have to evolve so that we can remain aligned with future spectrum allocation and use cases. So I think we got some great panels. Before we get started, I do have a couple of housekeeping items to get out of the way. First of all, today's live stream broadcast is going to be available for viewing on the Event Mobi platform a little bit later today, and you can find that on the main stage Day 1 tab. That content's going to be available for viewing until December 21st, and then in early January, all the content from the next 2 days is going to be made available on YouTube, and we'll notify you all when it's being posted. In addition to the live content, we do have one pre-recorded session. It's called Setting the Stage for Current Controversies on Spectrum Use. And this recorded content's available on this platform under the Agenda tab. And then you just click on the pre-recorded session to pull up. It's a 26-minute overview that includes some background on radio spectrum, how aviation uses it, how spectrum's allocated at the national level, and the international organizations that are involved in that allocation, and a lot more. Now, we've also posted a document on the event platform titled Spectrum Compatibility Resources, and this document includes links to a white paper, some other webinars that we've done, and an update from the work from RTCA special committees and EUROCAE working groups on spectrum. And it also explains how you can get involved with some of our standards development work should you be interested in doing so. We also have some details about RTCA and EUROCAE on who we are and how to get in touch with us, and that can be found on the Companies tab. And for the sessions today, you can submit a question to our panelists by typing it into the field on the Q&A section of the Main Stage Day 1 tab. If you'd like a copy of any of the slides from today's sessions, just email us at membership@rtca.org. And finally, of course, we'd like your feedback on today and tomorrow's sessions on perhaps what you'd like to hear from us in the future. And at the end of the event, please visit the polls and survey tab to answer a very short survey. Now, our ability to bring you events such as this would not be possible without the generous sponsorship from our industry partners. And I'm especially thankful to the Airline Pilots Association and Garmin for sponsoring our Spectrum Summit this year. So let's get started. In aviation, there's three areas where we have some limited resources. Resources is in funding and people, airspace resources, and frequency spectrum, which of course is the topic of this panel. I'm often asked, what are some of the key safety issues that are going to be impacting the industry in the future? And some of the ones I come up with are fairly obvious, but one that's on my list isn't as obvious, and that's the allocation, deployment, and implementation of frequency spectrum. And I say this as a safety issue, not because of the use of spectrum is inherently dangerous, but I say this because we don't know what we don't know. It's not like icing or the potential for runway incursions, which you can physically see. We can't see frequencies, and we don't fully know the impact of what some of these new frequency applications on legacy designs and certification criteria are going to have, some of which these designs and cert criteria are 20 to 30 years old. We also don't have a natural venue for different government agencies to work together, or even for different industries to work together on some of the issues facing our collective industries. Now, the definition of aviation is changing. It's become an entire aviation ecosystem. We no longer can think of aviation as just being an airport to airport function. It's really moving to a front door to front door environment. And these rapid advancements in new technologies are behind this transformation. And it's not just on the vehicle capabilities, but it's also the required connectivity that's going to be needed between the components of this new ecosystem. Air to air, air to ground to ground are all going to require allocations of future spectrum. And that access is both going to impact our current use of frequency bands as well as future allocations that come up. So with that as some background of why we're excited about this and why we're involved with it, I would like to get started with our first panel. And I'm going to invite our panelists to join me on the virtual stage, if you will. Now, we're all very familiar with the issues around the implementation of 5G that we've been dealing with for the last year to two years. There was a lot of conflicting messages reported in the press. There was public confusion and some disagreement about the levels of risk that might be involved. And there certainly was a meaningful lack of communication between the different industries early on in the implementation process. And this intersection of diverse industries in the spectrum domain with vastly different approaches to operations really has resulted in and required some more interaction across formerly unrelated industries. And key stakeholders are what we have today to talk a little bit about some of the lessons learned and perhaps even propose a path forward. So to get things started, I'm pleased to introduce our first set of panelists. I'm going to introduce our moderator for the panel, Captain Wes Gouge, a graduate of The Ohio State University in 1979 with a Bachelor of Science degree in Aeronautical and Astronautics Engineering. He's gone on to have a stellar airline career as a line pilot, check airman, and airline technical pilot. He's currently American Airlines technical pilot for airspace and aircraft modernization and serves on several of RTCA special committees. So Wes, over to you and the panelists.
Thank you, Terry. Great introduction. I really appreciate it. To get started, I'd like to first introduce Dee Reimold. Dee was named the Director of Strategic Operations for the U.S. Federal Aviation Administration's Office of Commercial Space Transportation. In this role, Dee is responsible for policy development, international outreach, government industry collaboration, and an array of strategic initiatives to promote and sustain safe integration of commercial space activities into national and global aviation systems. Welcome, Dee. Our next presenter will be Ben Brandt. Ben Brandt is an aviation systems engineer and outcome leader overseeing the MITRE Corporation's civil military aviation integration and evolution efforts. Ben is responsible for developing and executing MITRE strategy to work across sponsor portfolios and the MITRE National Security Center's efforts to link airfields, airspace, and aircraft for synergistic mission execution in civil and military controlled airspace. As a part of his role, Ben chaired a bench test work group for the Department of Defense Joint Interagency 5G Radar Altimeter Interference, or JOFRE, quick reaction test from May 2021 through September 22. After him, our next presenter will be Dr. Robert Kebbel. Robert Kebbel is an Airbus expert in electromagnetic compatibility, EMC, and lighting protection. He is a leading industrial standardization in EMC and aviation, Eurocase Work Group 99, RTCA SC 234, and guided the first integration and certification of radio connectivity systems into the aircraft cabin. Dr. Kebbel is with Airbus in Hamburg. Welcome, Dr. Kebbel. Next in our list is Michael Mowinski. Michael has more than 31 years of experience on airport operations. With his background knowledge, he developed and introduced systems like flight data processing and other operational support systems at one of the busiest hub airports in Europe, Frankfurt. He also served as a senior manager of airside systems at the same airport. In this role, he was responsible for multiple operational airside systems. In 2021, Michael joined T-Systems International as Director of Airports at ATM. Our last presenter today will be Karina Perez. Karina is the Director of Unmanned and Emerging Aviation Technologies at Aerospace Industries Association. In this role, she works with AIA's members regarding unmanned aircraft systems, urban mobility and spectrum, and among other areas, and works to find industry consensus on complex issues facing the aviation industry. Karina is also the co-founder of Z-Vector Fellowship, an organization focused on providing internships to underrepresented communities in the aerospace industry. I want to welcome all our presenters, and we'll get started with Dee first, if that's okay. So Dee, in your job or your role with the FAA, Federal Aviation Administration, I'd have to ask you, since we deal a lot with you as well at American, what have you learned through the interactions with intergovernmental discussions and with other operators regarding 5G? Any thoughts you might have also on the FAA's AMOC process?
All right, Wes, yes. So yeah, I do have a few thoughts on a number of items that you've teed up. And before I get going, wanted to extend my appreciation to RTCA and Terry and to this panel. I'm thrilled to have a chance to chat with everyone this morning. Certainly, Wes, you teed it up perfectly. I mean, I think of the many items we would catalog as lessons learned from the 5G C-band activities over the last many years, is that really at the heart of any success that we've enjoyed so far has been partnerships. Certainly the partnerships that were called on and further strengthened among critical industry, aviation industry stakeholders. I look at some of the panel members here, and I know we've had many 5G related conversations. But equally important are the partnerships within the U.S. government itself, and then the partnerships that have been created between the two industry communities, between aviation and telecommunications. And really what those partnerships have resulted in and continue to be further nurtured, I would really underscore, is coexistence between aviation and 5G C-band is not only possible, it's happening, right? There are more than 50,000 active AT&T and Verizon sites around the US in targeted markets. There's going to be a whole lot more next year when 19 additional telecommunications entities enter the fray into the phase 2. So what I think we have really learned, Wes, is that tough problems require people to get together and figure out solutions. And we didn't have a ready-made solution to make sure that the national airspace system stayed safe. We had to create it through data acquisition, through analysis, through, frankly, just talking to each other, learning what the telcos were planning to do and how they operated. I mean, this is how bizarre it was in the early days as we were talking directly with AT&T and Verizon. They would say carriers, and we assumed they were talking about you guys, Wes, the airlines, and they were talking about the other telco carriers. So words mattered in our interactions, and we had to learn to understand each other. And, I would really, really underscore that not only have we learned a lot from each other, not just vocabulary, but our business practices. We've learned about what keeps each other awake at night. For us, having a really bad day in aviation, is clearly what keeps us up at night. For the telcos, it's having massive network failures, for whatever reason. So, and those kind of things, I think we're going to continue to learn from each other. Certainly, as I mentioned, 19 additional companies coming onto the scene in the next year. That's going to grow the markets that they are in from 46 when they got started, or a little less than a year ago, to more than 406. So, again, this is why the partnerships that we've created and the ways we've done business, we've learned to do business with each other, are so important, because we need to leverage those as we develop similar partnerships with, forgive me, my shorthand is the G19. It's the other 19 carriers. And I think it's a good news story. I would also share that we've already started talking with some of these entities. They're very interested in learning how the FAA and the aviation community is interacting with AT&T and Verizon, and we're only too happy to share that with them. Obviously there's a lot of sensitive data that we don't, and we've learned pretty good at it, about not sharing the data that one company can't know from the other. Some of the other lessons learned, I think, that may be obvious to the people listening to this discussion, but, between telco and aviation, it's clear we operate at two very different speeds. And what I mean by that is, there are new generations of phone service available. When you think about it, every time, my carriers are constantly calling me with the next best product. And that can happen, that can happen in a matter of months. That can happen year over year after year. And we in aviation just don't operate that quickly. And, that's something we can acknowledge, but I think it's important for the future that we try to figure out a way to reconcile that. The reality of that is, when we think about even the work underway, Wes, that I know you're involved with, and certainly sponsored by RTCA, on developing new performance standards for radio altimeters for the future, so that they are not as susceptible to new network services. But what that will mean is we got to figure out a better way of talking to each other, right? And learning what's in the planning mill for whether it's telco or others. And so I don't have that magic answer. There's a lot of things we can adopt, as I said, from our lessons learned, to figure out how do we engage as industries. How do we engage as industry and government partners, and frankly, as international partners? I look at my other panelists knowing, Anna mentioned there's different levels of activities going on globally in terms of 5G C-band, but we all do need to learn from each other. And when I think about all of that is, just maybe looking ahead, you take all of that, what we've learned and what we've experienced. And so what I'd say simply is we need to continue to nurture and develop the relationships, whether it's, with the new telecommunications entities coming in, could be new industries in the future. So we need to always be open and willing to meet with some new people and learn some new things. I would say the same thing in the U.S. government partnerships. We're very active right now, working with the FCC and the NTIA on some long-term mitigations that we have data-backed analysis that says that these long-term mitigations need to remain in place so that the NAS can continue to operate safely and effectively. And I think, frankly, leverage that, to the larger U.S. government and industry, just having that chance to introduce the different stakeholders to each other and having a regular venue for the conversations. As I said, how do we anticipate what the next best technology is or the next new technology is and get out ahead of it so that we are not, God forbid, in a situation like we were last year at this time. So as you know, Wes, I could go on about 5G C-band all day.
Oh, yeah.
I'll stop now and certainly be happy to answer any questions that anyone has.
Okay, well, that's great input. All great points, Dee. I think what I'm going to do now is pivot to Ben Brandt from MITRE. Ben, in your role as a MITRE lead for the DoD Joffre work, what perceptions do you have on the value need of bench testing to address the challenges presented with aircraft testing?
Yeah, thanks, Wes. And I have to agree with a lot of what Dee said. The collaboration is key. When we started the JI-FRAE activity, there was a lot of contention between the different industries and different government partners actually as well. So that was a huge activity to address. And really, I mean, it took us 8 months to come to an agreement on the test parameters that we were doing. From a MITRE perspective, we were just doing the bench testing, but the larger JI-FRAE activity was intended to do over-the-air testing through NTIA, and then doing some operational testing, leveraging DoD test resources. But one of the key things that came out of that activity is that testing in an operational environment and doing, specifically RF testing in an operational environment is very challenging because it really only provides an accurate representation of whether or not there are going to be impacts of that spectrum on a few or a single scenario that's being played out in that particular test event. So it's much more economical to do things in a bench test environment, but the challenge there is being able to validate it. And as we went along, the operational testing activity was progressing sort of in parallel with the bench testing, and we were learning from each other. But there was if we could go back and do it again, there was kind of a few key things that we would have done. One in particular was actually instrumenting the aircraft and everything possible that we could have instrumented on the aircraft. We did a lot of activity in just instrumenting to understand the 5G signal as it appeared at, I'll say, the skin of the aircraft or at the radar altimeter antenna. And then we instrumented the output from the radar altimeter to look for altitude anomalies as they were compared to some sort of truth source. And trying not to get into too much detail here, because as with Dee, I could spend hours talking about what we did and what we learned. But the key part there was I really wish we would have measured the output and receive power of the actual radar altimeter RF. That was something that we didn't do. That would have given us a little bit more insight into its behavior as it was looking outside of outside of its radar altimeter spectrum band into where the 5G is. And the slide here actually shows some of the operational plot, or some of the plots from our operational testing as well as the bench testing. Without getting into too much detail here, during the operational test event, which is shown in the pink, there was I apologize, actually, yes, the operational testing is in the pink or fuchsia color, but the bench testing is in the blue. And as you can see, in the lab environment, we had where there was a straight and level flight around the 50 to 100 second mark of that plot that's on the left-hand side. The there was about a 20 dB bias, but we did hit the peaks and showed the peaks of the side lobes as being consistent. So it, like I said, it was challenging because that bias could have been created by something on the aircraft or something that was in the natural environment, or just a measurement error because of something not being calibrated correctly. By way of comparison, the straight and level flight, you can see that there's about a 10 dB bias. And while the trend line is consistent, what we did to try to figure out what some of the error sources that were contributing to the operational test results as far as the amount of 5G power being received at the aircraft skin is we adjusted the antenna array by 1 degree in our model, and it reduced that bias considerably, and that would be the red dotted line there on that plot. So it really just is, it's a very complex testing of RF, and that's something that getting agreement between the industries and the I know there was a lot of contention that played out very publicly as far as between telecom and aviation in regards to some of the earlier testing that had been done. But again, as Dee said, there was a lot of unknowns and what the data was and how the 5G signal was actually formed that was just not available at the time. And we learned a lot through the JI Frey activity, which is available for sharing with industry partners as well as other government agencies and government entities globally. And we just have to go through the steps of doing that. So that's probably it's a little bit more from a tactical level as far as the actual test execution, as far as lessons learned. Really, I think to get after where understanding what the full impact is. This is not the first time we've seen spectrum issues in aviation. There was FM immunity caused, for iOS receivers caused by VHF radio stations. And then also GPS a few years ago. So this is not our first rodeo into spectrum concerns.
It's all good points, Ben, all good points. Well, let's see, Dr. Keppel, looking at your work, you've been working on the use of portable electronic devices on aircraft and connectivity in aircraft cabins for some time. Do you see any parallels between that work and the current 5G discussion?
Well, in this extent, it's really the first time that we had a spectrum expansion of a useful signal of a non-aviation radio system starting to interfere with an important navigation system where it becomes sensitive. The situation had for a short time really cast a shadow on the effort to enable and operate connectivity on board. A number of discussions came up whether or not usage of mobile phones on board or mobiles on board would have to be considered as a threat again, as was the case 20 years ago. Today, I think it's good that the aviation industry could demonstrate and provide the methods to demonstrate that the mobile devices, PED, polytronic devices on board, are not an issue. And for this purpose, it is critical that the aviation industry agrees on industry-wide acceptable standards, as we've developed them before in RTCA and several RTCA committees, not just the Working Group 99 and the SC234, but also the other working groups such as SC242 and Working Group 124, which are active right now on spectrum separation. Today, you cannot think of modern aircraft without the capability to employ wireless, Wi-Fi or Bluetooth services also inside the aircraft. It's a generic feature which all the new modern airlines have, which all the aircraft, where there's a demand for. Cargo trackers or passenger infotainment rely on compliance and therefore also on spectrum sharing of mobile devices with the aircraft radio systems. And the aviation industry also made efforts for setting the framework for this in European RTCA and with the aviation authorities. In Europe, for example, efforts have also been taken to protect the terrestrial networks from operational interference of airborne mobile devices. So this is happening. And a spectrum allocation also, if you think of 5G, keeps a wider separation from navigation spectrum in the European airspace. Well, finally, the joint Working Group 99 and SC234, based on inputs from SC239, could demonstrate that large transport aircraft do not have a general issue with the 5G portables on board. But further attention needs to be put on terrestrial base stations. And for me, it is of critical importance that spectrum sharing is coordinated between aviation, non-aviation applications, and the actors, including the non-aviation actors, find together with the aviation industry solutions for the various applications a priori. And this way, I think that initiatives like the now ongoing also SC242 and Working Group 124, where my colleagues are working in, are essential and should be supported by the entire Spectrum Regulation Committee. That means spectrum allocation needs to consider and reflect the constraints of affected industries. And this is a common effort, and not just RTCA and EUROCAE, should also include the inputs from the telecom communication industry, and vice versa. It needs to be a compatible solution finally. And again, what D. Reynolds said in the beginning, we are working at different pace sometimes regarding the development of telecom applications and the radio navigation community. So that needs to be considered as well.
Great points, Dr. Kebbel. I would totally agree with the fact that we are an organization that, or an industry that does have quite a variance in timelines between what we do and what other non-aviation interests do. Michael Mowinski, in reading your bio, you have extensive background in airport ops, especially at the Frankfurt Airport. Given that extensive background, and of course your background in development of multiple airside systems, how does that compare to our current 5G discussions?
Yeah, thank you, Wes, for introducing me. And first of all, thank you very much to RTCA and EUROCAE for organizing this exciting panel and with a lot of experts and great speeches here I heard so far. Well, 5G at airports is a very important and critical topic. When I got first involved in that matter of 5G, it was in 2020 when I first was approached from different directors from airlines, from the own organization. Former organization was Fraport, Frankfurt Airport Authority. Does this incident, or let's say this case, also impact the airport operations? And at that time, it was really unsure. What also was mentioned by Terry and by Dee, it was a very blurry situation. It was not clear, does it affect the airport operation? What is the real problem? So was it a problem for the airport or not? It was not very clear. And from my experience in the past, I had some similar case. It was on the 1090, 1030 megahertz when I was trying to certify a multilateration system in Frankfurt. It was previously certified in the US. And then we want to install it, deploy it in Frankfurt for our new runway, or for the new runway in 2011. And it turned out that the requirements were a little bit different from FCC, from ICAO, from the European requirements, from the European directives, and also even with the local requirements from the local government. So there were some small differences between the testing methods and the requirements, the operational requirements. So the problem was we need to deploy the system, but to get the certification from the local authorities, we have to undergo a separate new study and a new certification process to get the approval from the local authority. So at the end, it went successful, and we had no incident at that point of time. And obviously, the runway turned into operation in 2011, and our former Chancellor Angela Merkel could land as planned on the new runway. But it has shown that it's obvious that we need to harmonize the, let's say, maybe, or revisit the compliance requirements, and maybe also certification requirements and testing environment. And Ben also mentioned that the RF testing is very complex very complex to test it in the operational environment. So, and I think 5G is the 5G case showed it. This is the similar problem here, and 5G is a very important technology for airport operations. Not only from an airport operator point of view, also from a service provider point of view, a telco provider. So we have to rely on the regulatory environment and to follow the regulatory environment. The uncertainties in the procedures and methods, how to deploy such technologies. So this is very crucial that we make a harmonization across the world, because 5G is not operated only in US, Europe or Asia. They're working in a similar C-band, yeah. But of course, in Europe, we do not have this severe problem at the moment. At the moment, I say, because we are only using the 5G frequencies up to 3.8 gigahertz. In the US, it's up to 3.9. In the Asia part, it's already up to 4.0. They are much more closer to radio altimeters. But of course, in Europe, we want also to use the frequency up to 4.2 gigahertz. So it's very important that we continue to investigate what is really causing problems here. So Terry mentioned in the beginning, in the opening speech, the airports are an ecosystem. I can underline this very clear. Everything comes together at the airport, at the ground, and what is really necessary that we use such new technologies like 5G, because it's very important to use other means for cockpit ground, or air-ground communication, and to transfer data from the aircraft to the ground. So what is very important when it comes at the airport together, we need harmonization. I need to emphasize this all the time, harmonization of the work to be done at RTCA and UKA to ensure that we can define the operational requirements from the involved verticals. So that's not only the aviation, but also telco or cargo industry or transport, which come also together at the airport or at the airports. But what is really critical is to finance this work to be done. We have a lot of voluntary people and organizations who contribute to the standardization work, but it's very important to emphasize also in the organization that this work also secures the CapEx investment at the airports for deploying new technologies. So in a nutshell, to conclude my way forward, we know that there's still a study undergoing from ECC PT1 on this matter. So we need to have this study and the results from the study to take on into account in the future, let's say, standardization and harmonization work. And maybe we should also review the existing standards and procedures for the certification of the equipment to be deployed either on the aircraft or on the ground. And yeah, try to find a way of harmonized minimum operational standards we typically develop in that area to be used all over the world, not in a specific area, and this should be harmonized. So thank you, Wes.
Great points, Michael. Great points all. Matter of fact, I wanted to circle back to Ben real quick, because I know there were some points that he wanted to make, and may have cut him short a little bit. But Ben, if you want to hit us with a couple of lessons or pathway forward, I should say.
Yeah, no worries, Wes. I wasn't sure if you were going to ask another question or not, but yeah, I agree with what Mike just said as far as the way forward. RTCA and URK are definitely taking the steps that they're doing to work together in identifying those critical aviation spectrum resources in SC 242 and Working Group 124 is key. And as I said, this isn't the first time we've seen this, so it's only going to happen again. It's just a matter of time. But getting ahead of that will help in really maybe not necessarily matching the speed of the telecoms, but at least get aviation moving and the ship turning ahead of time, so that we can, provide spectrum authorities globally what are some of the concerns and what are some of the key spectrums, especially for some of the safety related systems that we need to be concerned about, and getting that word out there so that we can start building that coalition now as far as the stakeholders who may be interested in that spectrum or operating near that spectrum and having those conversations early. And then with respect to 5G specifically, getting agreement between the industries on the models that are used for doing AMOX or any other additional testing, it really is key. Like I said, we spent about 8 months just trying to get to that agreement, and we did under the JI Fray activity. But one of the key things that was determined during the JI Fray was the fact that there was not spurious emissions from the 5G towers into the rad out band, but it was definitely more of an issue of the radar altimeters having that, looking outside of the allocated band. So receiver standards are being talked about by the FCC. That's something that aviation needs to follow closely. But any other further interest in that, I'll say those test results from the JI Fray, as far as the the 5G tower performance, really, Frank Sanders at NTIA would be the key person to talk to about that. And then also from a MITRE perspective, we're continuing to do some additional testing for the DoD, looking at the UK, Japan, and China, where those frequencies, as Michael pointed out, are much closer to the rad out frequency, and determining if there's an impact there for the US DoD, at least at this point. Over.
Great. Thank you, Ben. Now I'm going to turn to my last panelist, Karina Perez. Karina, your work at Aerospace Industry Association has been key, in my opinion, to pulling together so many in the aviation industry together into a coalition to address the 5G issues. Can you elaborate on your observations and takeaways during this process?
Yeah, and thanks, Wes, for that. You have been extremely helpful in getting everyone together, especially on getting the perspective from the people who actually get to be flying the planes and your concerns. One of the things is that we've been at this issue since 2017. So we've been at this for a little while, and I think it's important to talk about the lesson learned of the timing and being able to do this early on. And I know that a lot of this was mentioned throughout the other panelists, but aviation takes time, safety takes time. And so when we look at other bands that are going to be used, we need to look at who might be impacted, who is currently either in the band or next to the band, in order for us to have enough time to do this. We understand that the timelines and technology are different from industry to industry, and we're not against 5G. If anything, we, as Michael mentioned, we benefit in different areas. It's just a matter of doing it safely and timely. And so that is one of the things. So one of the other things is making sure that the expertise from FAA and others are taken into consideration as we move forward. I think a lot of what we're really seeing is areas where additional agency or industry input would come in handy before the auction even happens. And I think we had a couple of opportunities. Unfortunately, we didn't get there, but FCC and NTIA have a very difficult job in getting these licenses out. But now we have the opportunity to use these lessons for the future, especially as NTIA and FCC look at their next 15-year plan. It's important for us to come in and be a part of those conversations, be a part of what the decision's going to be like, because we don't want to be in this situation. And as Ben said, this is not the first time we're in this situation, and it won't be the last. So we need to start those conversations now and start them early. We have, as AIA, also pushed for some congressional support in establishing more pathways for that, for industry and interagencies collaboration, so that it's not just on the FCC, because like I said, it's a very difficult job, and they can only have insight into so much. And so we want to be able to give that feedback. And so we're also pushing with Congress on that to provide some change in the in how it's allocated and licensed, and things that can happen before the auction. because again, we in aviation require kind of a long runway, no pun intended, for us to meet safety. And we also did see aviation come together and work at a speed that I don't think it's used to or sustainable in in all reality, with the amount of work that has been done and it's getting done. But we really need that time to be able to either retrofit or change things. And I know when you're talking about receiver standards, we definitely need time on that, and we need to make sure that we're well aware of how that plan is coming, so that we can plan out not just on the work but also on the financials of it all. That's one of the sticky subjects of all of this, is the amount of work and money that has gone into solving the issue. And it's coming all in a fast timeline, a compressed timeline, but with more time, it allows for airlines, OEMs, and everyone to really build up the business case in the long run, and not have to do this at a very compressed timeline and at an expensive timeline, I would say, for both aviation and telecom. It's something that we haven't discussed as much, but it's something that is definitely impacting both industries. And as Dee said, both industries have their priorities, and both industries need to continue to work, and we just need to work together early on to avoid where we are now and where we have been in other situations. We have the opportunity, and I think everyone outside of our circle is starting to realize that too, from Congress to the administration and the White House. They're noticing that we need to have these conversations early, because nobody wants to be where we were last year. And I know, Dee, we bothered you so much, and thank you so much for all the work that you've been doing over the last year. It's time that could have been spent also on something else for the FAA, time that could have been spent on something else for aviation as a whole. And so we need to avoid where we are now by thinking early. Now we're trying to solve this issue, and this issue is going to be an ongoing thing for the upcoming, I would say, couple of years. But for the other issues, we are in a good position to work with FCC and TIA, FAA, and all the other agencies that need to be involved, and all the other industries that need to be involved, so we can coexist without these problems in the future. And it really takes everybody coming together, at least from the coalition perspective. We were meeting we meet every week, twice, 3 times a week to get this done. And but with time, we can definitely do this. We can do this, I would say, better with more resources, and we're willing and able to work and come together. We just need that time. We need the leeway to be able to do this.
I can certainly agree with that, Karina.
I'm sure you've seen more of me than you want to see.
Well, from our perspective in the airline side of this, dealing with the carriers through different committees, RTCA, all the other groups that we've been involved with over the last year and a half, we've picked up some lessons. I think, quite frankly, we considered the radio altimeter to be a very basic instrument. Nobody gave it much thought. It just sat there in the panel. It did all the functionality that it did in the beginning. What we didn't in the industry realize, as far as the operator is concerned, how much integration had been utilized with this radio altimeter for basically functions of turning things on and off. Whether it was in the automation, the flight control system, or if it was in the warning systems we have, with this terrain warning, predictive wind shear, reactive wind shear, all these different devices now are plumbed in to a radio altimeter. So that was a big aha moment for us, is that we went back and looked at all the pieces this thing hooks into, because for us as a flight crew member, it was pretty basic. It gave us a way to measure height above the ground for instrument approach procedures, as far as when to either see the runway or abandon the approach and go around. It also served a big function on the auto-land feature, but then it served a lot of function in some flight control functionality that dealt with how the airplane operated in this new environment where there's so much more automation in the flight control system beyond what we used to have back in the 70s and 80s and even the early 90s. You know, the whole process that we worked through, of course, with AIA and others, and then moving in with Dee and her group, the FAA with the AMOC process, that was another opening encounter. We probably spent multiple thousands of hours going into January of this year, getting prepared for what we thought, until it was ultimately worked out that there would be some mitigations by Verizon and AT&T, the ability to continue to operate into airports with low visibility ops, and also some of the other approach features that we use. Beyond that, we also learned that some of our OEMs, the airframers, were going to impose certain ADs on our airplanes based on that integration level, again, that the radio altimeter faced. So this has all been a huge education for us. To your point, Karina, and to the rest of you, to all your points, the communication piece has been really important. From where I sit, listening to a lot of the discussions in several of the groups, the one thing I've been taking away is that we have in our world a distinct understanding about safety and how it plays into the operation of air transportation, whether it's in an airline or a charter outfit or air ambulance or any of those features. We understand what we need to do to make sure that the passengers are safe. And then we deal with industries who, for various reasons, they provide services that don't have that same safety risk that we do. And so through the evolution of aviation, is from an air transport perspective, through the accidents we've seen, you know, both with loss of life and injured individuals, we progress forward. That's why all these systems have been built. That's why we do the work that we do to ensure that every flight is as humanly safe as it possibly can be. And to that point, which you've all made, time is a component of that we have to exercise. We have to have enough to do the testing, do the analysis to make sure that we meet the goals the FAA and Dee's group has set for us as far as assurity and reliability, so that we know that when we take that product out in the NAS and we fly around with you in the back of our airplane, we know we're giving you the highest level of safety that's humanly possible. Because at the end of the day, for us as a business, that's a huge part of our commitment to you as passengers, that we're going to do that safely. And the training we give the pilots, the systems that we buy from the OEMs, and then how we conduct our operations day in, day out, that's hugely beneficial. And I think that gap in understanding how that development process of new systems in an airplane is dramatically different than what it is for other industries. Because wireless, as you said, Karina, they can come up with a new cell phone, you know, an i14 in 2 years or less, or from an i12 and from an i7 and i8 and so forth. We don't leapfrog that quickly. And from an industry standpoint, as far as the airline community is concerned, we faced COVID like the rest of everybody else did. And for us, it was a hugely expensive challenge, which we have gotten through, and we're still working through it. But at the same time, as we work through this retrofit process that you mentioned, putting these new radio altimeters in our airplanes to get us to the next generation of radio altimeters that will come 6, 7 years down the road, that's another expense. And it also is affected by COVID, because supply chain issues have actually caused disruption. And the OEMs, the avionics OEMs, who have been able to get certain components, whether it's cables, connectors, epoxy, something what we consider to be simple. As we go to the store and buy things, we think, well, it's all kinds of stuff. But supply chain has played a factor. And so that produces a drag, like, you know, on us being able to meet the goals that we now have set for July of next year to have all our radio altimeters and the transport category aircraft retrofitted. So quite frankly, the challenge is there. We're up to meeting it. But there is going to have to be allowances of the fact that, as you mentioned, we don't sprint through these processes. We do take our time because we absolutely have to be sure that the safety side of it is met so that we don't produce any additional safety risk into the national airspace system or anywhere in the world for our passengers, because it's just not acceptable. I mean, you know, you can have all the awards and accolades, but it only takes one accident, and the next thing you know, you start all over again. And we just can't afford to do that. We don't plan to. So with that being said, I see we're coming up close to our time. I want to personally thank all of the panelists who joined me today. They're all experts in their own right, and I certainly appreciate all their very valued comments. It's been very rewarding for me to spend the time with you to discuss this topic, and I hope that we can all continue to work together to bring this whole effort to a conclusion and a pathway forward that not only us, but other industries can understand, appreciate, and respect. So Terry, I'm going to bring you back on stage, and I know you have some closing comments, but again, thank you for the opportunity to host this and moderate. Thank you.
Well, Wes, thank you. Really no closing comments. I think you all covered things so very well. Dee, Ben, Dr. Kevo, Michael, Karina, thank you for those words. Thank you for your participation today. I know we've learned a lot over the last couple of years, and I think you all expressed some of those learnings very well. And certainly those lessons have put us on a great path forward. So thank you again. Appreciate your time.
Thank you.
Thank you. We'll see you.
Thank you.
Thank you. Bye-bye.
As a reminder, if you would like to submit any questions for our panelists today, you can do so on the Q&A section of the main stage day 1 tab. And we're not going to get to all of the questions during the live sessions, but any questions that don't get answered, we're capturing all those questions, and we'll get as many of those answers out and posted on our website here in the near future. So let's transition to our next panel for today. So I'll invite them to join me on stage. Unlike in aviation, which is regulated almost solely by authorities specific to aviation, aviation spectrum is regulated both by aviation and telecommunications authorities. So in this session, we're going to bring together both sides to discuss spectrum regulations as they exist in the United States, in Europe, and also in a broader global context. And I'm pleased to have Mr. Steve Kramer moderate this session. Steve has served as the director of the Air Navigation Bureau at ICAO since April of 2015. He began his career in air traffic operations as a private pilot. Steve previously has held a number of executive and managerial positions at the FAA. He has over 33 years experience in the air traffic and international aviation organizations. He also served as a member of ICAO's Air Navigation Commission as well. So Steve, thanks for joining us and welcome. I'll turn things over to you.
Okay, thanks, Terry. It's a pleasure to be with you this morning, and I want to thank you and RTCA for the opportunity to join this panel and moderate this discussion. It should be very interesting, and I hope that the audience has a chance to interact with us. You all have the interaction methodologies that have been laid out in the administrative areas, and we'll look forward to the questions that you may have. Let me first briefly go through and introduce our panelists in the order that they're going to be speaking in, and then we'll jump right in. With us, we have Sandra Wright. She's the manager of the United States Federal Aviation Administration Spectrum Planning and International Office. Serving in that role, she brings 20 years of experience as a military, government, electronics and electrical and electronic equipment expert as an electrical engineer, working in radio frequency compatibility testing, radiation hazard, interference resolutions, etc. She leads a team that works on spectrum compatibility and policy for communications, navigation, and surveillance systems, including hot topics such as 5G compatibility, unmanned aircraft spectrum standards and policy, and commercial space spectrum considerations. She's currently focused on building strategic partnerships to enable new spectrum opportunities for aviation and champion aviation needs for a national spectrum policy and strategy and a World Radio Conference 2023 outcome that best suits the needs for future aviation spectrum. Following Sandra, Dr. Sunichi Futasumori is joining us from Japan. He holds a PhD from Hokkaido University in Sapporo. He's a senior researcher with the Electronics Navigation and Research Institute, where he joined in 2009. He's been engaged in the research of millimeter wave radar systems and electromagnetic compatibility issues, including radio altimeter interference due to 5G mobile systems. From the UK, Steve Green joins us. Steve chairs the European Conference of Postal and Telecommunications Administration's Electronic Communications Committee Project Team 1, which deals with mobile spectrum issues. This is the leading group in Europe on IMT matters and is preparing the CEPT positions on the WRC 15 agenda, including items 1.13, 911, 912, and 918. Steve is serving as a principal in the spectrum group at Ofcom, the UK regulator for communications in the UK, and he's leading international activities of the spectrum technology, engineering, and enforcement team. And then finally, we'll be joined by Hete Hokema. He is the chief expert on avionics and electrical systems at the European Union Aviation Safety Agency. He's been in the aviation industry for over 25 years, and his responsibilities include the development of regulations, policies, and standards in the fields of avionics, electrical systems, software, airborne electrical hardware, development assurance and flight controls, and in the consistent applications thereof. He's a chief expert supporting certification teams and providing advice to EASA management at all levels. He's also still actively involved in the certification of avionics at the aircraft and equipment level. Since he's joined EASA, he's played an active role in the development of policies on comm, nav, and surveillance, as well as specific policies in the different types of aviation. He's also supporting a number of groups at EUROK and RTCA, and is currently the EASA representative in the EUROK TAC and RTCA PMC. So this is a well-rounded panel with a lot of experience, and we'll dive right in and start with Sandra's presentation. Over to you, Sandra.
Thank you, Steve. And what a pleasure to be here with everyone today. I'm really excited for this opportunity to engage the RTCA Summit on topics that are very near and dear to my organization at the U.S. Federal Aviation Administration. The U.S. National Aerospace System relies on regular updates from critical radio frequency-based technology. And our office works to manage and protect those frequencies that they use and ensure that there are policies in place to support innovation for the future of aviation. COVID has definitely brought attention to the importance of connectivity and the benefits that can be gained, often through mobile, broadband, and satellite means. The FAA, though, has acquisition timelines where we often have to deploy and maintain equipment, planning for 30 to 40-year life cycles. And we've seen that it's been outpaced with this exciting pace of technology. While most discuss spectrum and the facts about it being a finite resource that has to be well managed, which I definitely agree to, my comments today are going to focus on the opportunities for innovation that our current spectrum environment has provided us. If you'll go to the next slide. This shows the US spectrum regulatory framework. And here in the US, all of the government users, including the US Federal Aviation, go to an organization called NTIA, where they support our agency mission needs. Industry goes to FCC, and they champion all of the industry needs. We come together at a monthly meeting called the IRAC, where we have regular engagement to discuss current policies, how they're working, as well as future upcoming systems. Next slide. This slide just shows a few of the radio frequency-based equipment that are on board a conventional plane that interacts with the National Airspace System. We are creating policies. When we're creating policies, we look at what mandatory equipment is, and this is a really serious topic. So as new entrants to the spectrum, we look to see how we can protect this equipment and not look to change with a new equipage to aircraft. Next slide, please. With our work within FAA Spectrum, we have definitely a lot of hot topics that have been going on. Recently with 5G, we've had opportunity to realize the importance of engaging with industry, and we look forward to opportunities as new spectrum entrants or requests come in, how to also improve that engagement with industry. We're looking at UAS, MOPS, and policies for different types of UAS. And then advanced air mobility is a huge initiative within the US FAA. We're also looking for ways to make commercial space integration possible throughout the NAS and what what communication, navigation, and surveillance systems are needed in order to make that happen. We look at other agency systems like Link 16, which is a defense system that's used globally. And then we're always looking at system-to-systems approaches. So how can we combine different systems and put them into one technology to reduce the amount of equipment maintenance and combine the technologies available? Part of that we did with ADS-B. And the ADS-B system was the first time that instead of the US FAA purchasing equipment, we purchased a system and allowed that system to be maintained by an external user. And we're seeing the benefits of that. We've noticed that there are opportunities for the very mature infrastructure we have in the United States of the communication backbone, and we're looking at opportunities to leverage that technology as well. So with these hot topics, they provided us opportunities to relook at our existing framework of how we do regulation and see are there opportunities to change, to improve, and to do additional outreach. Next slide, please. What we found is as we do outreach to the various communities that we engage in, these strategic partnerships have been key about learning what concerns we have globally. So groups like ICAO, where we attend the Frequency Management Spectrum panel, have been key in understanding what aviation needs are right now and for the future, as well as items like the ITU, the International Telecommunications Union, where we work towards the World Radio Communication 2023 agenda and make sure that we're positioning aviation correctly in the future. I look forward to building additional strategic partnerships, and I welcome your thoughts about other ideas of how we can engage. Thanks, Steve.
Thanks, Andra. Sorry about that. So I want to reflect that what you've outlined for us is a rapidly changing environment with a wide variety of stakeholders at both the industry, then in the US government, and then internationally at all levels. What a complex soup. So we'll look forward to talking about how we can innovate in that soup here in a few minutes. Sunichi, over to you, sir.
Thank you. Yes, thank you, Steve. And it's honored for me to attend this session. And hello, everyone. My name is Shunichi Tatsumori from Aircraft Navigation Research Institute, NRI. Our institute is National Research Institute of Japan and working for the developing future ATM CNS system. As a National Research Institute, we are investigating the aircraft radio altimeter and 5G mobile system interference issues. Today, I'd like to introduce the situation in Japan as a typical case. Next slide, please. Yes, first of all, I would like to start with the brief summary of RA and 5G interference issues in Japan. In July 2018, Information and Communication Council, Ministry of Internal Affairs and Communications, which is spectrum regulator of Japan, published the investigation report to harmonize the aircraft RAs and Japanese 5G mobile system. And in April 2020, four mobile phone companies launched commercial 5G service using the frequency band from the 3.6 gigahertz to 4.1 gigahertz and 4.5 gigahertz to 4.6 gigahertz. We can see the guard band for the RA band is 100 megahertz, which is different from the other countries such as the US and most of the European countries. And in addition, the 5G mobile communication system is operated in both sides of the RA band. However, in response to the RTC report on the interference issues of the RAs and 5G, aviation stakeholders in Japan, such as aircraft operators, JCAB, and ENRI, hold the working group at ATEC which stands for the Association of Air Transport Engineering and Research, collaborating with the MIC and mobile phone companies since April 2021. We understand that the Japanese spectrum conditions surrounding the RA is something special compared with other countries. Because of this, currently the spectrum sharing conditions of RAs and 5G mobile system in Japan are being validated by the ATEC working group using the newly obtained experimental data and RTCA local technical guidance document. Next slide, please. This slide shows the current activities of ENRI. We participate the ATEC working group for discussing the RA and 5G interference issues. This year, we conducted 2 measurement campaigns at the ATEC working group, joint and collaboration with the All Nippon Airways, All Nippon Helicopter, Japan Airlines, and JCB Flight Inspection Center, Japan Coast Guard, and Nakanihon Air. Figure on the left-hand side is the RA interference characteristic evaluations with Japanese 5G conditions, especially with the narrow band. We investigated the 20 RAs in total, in 12 for the large fixed-wing aircraft, and 8 for the medium and small wing aircraft and helicopters. And here on the right-hand side is the RA interference path loss IPL measurement, which evaluate the effects of the 5G mobile handset inside the cabin. We carried out the IPL measurement using several types of aircraft, including the fixed-wing aircraft and helicopter. RA 5G issue is one of the ENRI spectrum studies, but we also participated in several RTCA and Eurokai working group shown here. And next slide, please. Going back to the issues of RA and 5G, I would like to discuss 5G frequency allocation and current mitigations. This figure shows the sub-6 5G frequency allocation in Japan. Public 5G network is operated in 3.7 GHz band, which is 3.6 to the 4.1 GHz, and 4.5 GHz band, which is 4.5 to 4.6 GHz. In addition, the private or industrial 5G network is assigned for the 4.6 to the 4.9 GHz. Maximum ERP for the public 5G network is the 60.8 dBm per megahertz. As a mitigation measures, limitations of the installation locations are applied to the adjacent band. Figure on the bottom show the 5G restriction area around the airport and heliports. Rectangle area are in the red, showing red color from the line edge, which length is 1,000 meters, and surrounding area of the rectangle area, which is the 200 meter restriction area. No 5G base station is allowed in this area. And in addition, the restriction area of the heliport is inside the red circle, which diameter is 50 meter or 20 meter, depends on the transmitting power of base station. Currently, this restriction is only applied for the base station with the 100 megahertz guard band. There's no limitations for the base station with more than 200 megahertz guard band. Next slide, please. This picture shows the satellite view of the central Tokyo. Central Business District is located on the left-hand side. We can see that Tokyo International Airport, Haneda Airport on the right-hand side. In addition, the Tokyo Heliport, which is one of the largest heliports in Japan, is located on the top of the picture. And orange area is the restriction area of the 5G mobile base stations with 100 megahertz guard band. The sub-6 5G mobile base stations are still being installed and not spread across this area, especially for the base station operating 100 megahertz lower than RA band. However, we understand the frequency condition in Japan are getting more severe for radio altimeters in near future. So we will plan to carefully investigate interference. Finally, I would like to mention the importance of the international standards. The standard development carrying out by RTCA and EuroCAE is very important for us because the safety of avionics cannot be accurately assessed by only one national spectrum regulator. We look forward to the future publication of the guidance document on the radio altimeters. Thank you very much.
You know, I haven't, it's clear I've been on leave for the last week. I've forgotten how to use Zoom. I apologize. So Dr. Futatsumari, thank you very much for your very clear and detailed briefing. I'm looking forward to getting into some of those details and the questions. Next up, we have Steve Green from Ofcom. Steve, floor is yours.
Thank you, and good morning to everyone. Good afternoon from the UK. So I'm chair of ECC PT1, which is a group within CEPT, and I thought as an introduction I should explain what CEPT is. It's an organisation of European national regulators in spectrum, and there are 46 member countries there, and you could see there, and obviously 46 countries in what is a fairly small geographic area means a lot of international borders. So there's a definite motivation for regulators to get together, come up with common policies as far as possible, and harmonize technical regulations, because the other thing is for the market size, individual countries are not a sufficiently large market for equipment, especially for mass market equipment. They do create quite a significant size economic bloc, and so where we can harmonise technical conditions for spectrum, that's a benefit to those member countries. So within CEPT, we develop a number of regulatory deliverables. We have ECC decisions, which are in areas of significant harmonisation. Now, although it's called decision, it is not mandatory or binding on the members, but the signal got together and created this document that they call a decision, that it indicates there is a significant will to implement that. And in fact, we have an online, there's a website maintained by CEPT, which indicates which countries have implemented the decision, and the intention is as many as possible should do so. We also have recommendations which are more about indicating national options and frameworks that can be put in place, and we have reports which are effectively technical studies, and they're usually done in support of the work towards a decision. Now, we don't develop specifications or standards in CEPT. There is a separate organisation called the European Telecommunications Standards Institute, which does telecom standards. But for CEPT, our focus is really on the spectrum regulation. Like I say, it's what national regulators would normally do, and we aim to get together and try and come up with common policies there. So next slide, please. So within CEPT, we have the Electronic Communications Committees, as distinct from the postal side, and in the ECC, we have a number of project teams dealing with different subjects. So we have project teams dealing with satellite issues, for example, fixed links, short-range devices, and so on. And the group that I'm chairing is PT1, which is focused on mobile network issues. So 3G, 4G, 5G, and at some point we'll be looking at 6G. And what we do is a combination of the harmonization measures for spectrum that has been identified internationally for mobile. So, for example, we recently worked on the 26 gigahertz and 42 gigahertz that came out of WRC 15, and we have also been recently looking at the impact of active antenna systems and what that means for existing regulations. And in fact, we've been updating some of our regulations so that they reflect the option to use active antenna systems. And we also prepare for WRCs. And for this conference, we're looking at, in fact, we're looking at 1.2, 1.3 and 1.4. 1.2 is the one that deals with mid-band, potential additional mid-band spectrum, including the upper 6 gigahertz. 1.3 looks at 3.6 to 3.8 gigahertz across the whole of region 1, which is Europe, Middle East, and Africa. And then 1.4 is looking at for high altitude based stations, which is located on, for example, located on airships at very high altitude to provide. One of the key things that we're looking at right now, and we've been asked to look at by our parent group, is the coexistence with radio altimeters. So you can see the diagram at the bottom. We've got a big rollout across Europe of 5G in 3400 to 3800. So it's a slightly different boundary to the one in the US, and then there's 4200 to 4400. So we're trying to look at the issues of coexistence between those two, and to do some analysis on that. We've also recently been asked by the European Commission to look at a possible harmonization measure for low and medium power local access. So this would be different from the mobile network type deployment that you see for 5G in 3400 to 3800. This would be more of a kind of an industry, or what they tend to call verticals deployment. So it would be private networks around, say, a business park or for an individual. And so it would be, instead of a national rollout, it would be located in specific geographical places. And that's why it's a low and medium power approach. With high power, you would not get the density of deployment, so you'd have to have huge separation distances between different users of that. So keeping it low and medium power keeps it appropriate to the sort of coverage that we're talking about, but also means you have not such a large separation distance. And hopefully that will be a good neighbor to radio altimeters because of being at a lower power than the 5G type networks that you get lower down in the spectrum. So we've been asked to look at that, and specifically including potential coexistence with radio altimeters. So that's something that's kind of just coming on stream. So in the UK, in fact, we've already got some networks running on that. And this is looking at a potential harmonization across Europe. So next slide, please. And for our work on the coexistence, we have 3 meetings per year of ECC PT1. Each one is a week-long meeting, but we have lots of subjects, as you can imagine, to discuss in there. So we have to schedule particular slots for each subject. So those meetings are operating as hybrid meetings, which means we're meeting in a physical location. Our next meeting is in January in Edinburgh, in fact, but we also have online participation. So and request to speak and take part in the meeting that way. We also have, between those main meetings, we have what we call correspondence groups on specific subjects. One of those is focused on the radio altimeters topic, and we've been scheduling those for what's afternoon in the European time zone, so that it facilitates participation by those in the US and Canada. And participation in our meetings, as I indicated on the first slide, it's a forum for national spectrum regulators, but our rules of and our working methods also allow participation by industry. So we have members of the mobile industry, and we've also been having members from the aviation industry participating in the meetings. So we aim to facilitate that discussion by the relevant and do it as much face-to-face as possible and directly, rather than having to go through a national administration. So what have we done so far? Well, we've been gathering the technical parameters for the different systems, so all the 5G parameters. We're also still just low and medium power parameters. So for example, what do we mean by low and medium power? What exact power limits we're talking about, and what sort of deployment scenarios there. One of the things that has slightly delayed our progress is that we were waiting on critical coexistence scenarios for radio altimeters. Obviously, a key thing if you're going to do the analysis is which sort of geometries do you need to look at for the analysis. And we, in the autumn this year, we received a copy of the guidance document on radio altimeter RF interference rejection and tolerance, which I think came out of our RTCA. And so that was sent to us during their open consultation and FRAC period. So we were invited, obviously, to put in comments there. So we won't be putting in, or we haven't put in a PT1 comment for to put those comments in. Of course, that we're aware that that closed, I think, on the 2nd of December. So, but that's really useful for us to see what the latest thinking is on radio altimeter performance, and also to have that information on the critical scenarios. So that concludes my presentation. Thank you.
Thanks, Steve. And now, Ete, it's over to you for the closing presentation before we go into the questions.
Thank you, Steve. When Steve was presenting CPT, I realized I should probably have presented the role of EASA in Europe, and how we share responsibilities with our member states, but I haven't, so I apologize for that. Maybe I should do better next time. I should also apologize for the fact that you may see some rather provocative statements on these two slides that I'm going to present to you, and that's intentionally done so. The reason for that is that I believe that if we, as the aviation industry, do not ask ourselves those questions, the IMT industry, regulators like Steve will ask those questions from us. So we need to be prepared to answer those. That's not to say that I always agree with what we put here, but it's certainly a discussion that I think we should have as an aviation industry, as aviation regulators, to make sure that we prepare ourselves for the future in the best possible way. Now, historically, aviation has been applying a rather conventional approach to spectrum, and the question really is, should we do something different? I think, I mean, what I've come to realize, in recent years, is spectrum is a really scarce resource, and we need to learn how to better value the spectrum that we use. Just to look at that radio altimeter spectrum that everyone's talking about these days, that's worth billions. And I'm not saying, I'm not trying to argue that aviation should pay for its use, but we should know how to value that. It is a very scarce resource. It's precious, and we need to use it in the best way that we can. We need to manage it in the best way that we can. I've also come to realize that the 5G case is not unique. It's not the first, and it will probably not be the last case of potential interference. So we need to, continuously pay attention to spectrum. That is an absolute requirement. And coming back to the case that we've seen Ligado, LightSquare, and GNSS in the US. We've seen a discussion with PMSE and DME in the UK. We've had FM immunity in the past. So that just shows that we shouldn't think that when we solve this 5G case, that's it, and we can all sit back and relax. We need to stay vigilant. And so I'm really wondering if a new approach would be needed. One thing's for sure, we need to learn to manage our spectrum more efficiently. And when I say that, I don't mean the way that we manage spectrum in the way of, where do we put it, but we need to make sure that our systems are designed such that we are robust and that we're good neighbors to to the other spectrum users. So when I talk about spectrum efficiency, it's really applying the latest technology to make sure that we use that spectrum in the best way that we can. We also need to be quicker to adapt. We have, in a way, seen part of that in the 5G case, where I think the aviation industry has responded much quicker than we've ever seen in the future. But it's really resource intensive. It takes a lot of resources, and I'm not sure that is sustainable. But we need to think about better ways to adapt more quickly to changes in spectrum. And here we go, probably for the most provocative statement on this slide. Should we perhaps be a bit less dogmatic on what we view as protection? Now, don't get me wrong here. We're not ever going to compromise on safety, never. But we may be able to look at new technologies to do, more in terms of sharing, more in terms of better protecting ourselves, but not necessarily in the way that we protect our spectrum today with guard bands, etc. So next slide, please. And I think that this new approach also implies reaching out to our neighbors. I was watching one of the earlier sessions, and Dee Rijmold, I think, had the exact same message. We need to foster direct communications with other industries, be it the broadcasting industry, the mobile industry, spectrum regulators. It is important that we do that, and I'm very glad that some of the IMT members in the CPT actually reached out to me, and I had some very good discussions. I learned an awful lot about the way that they operate their systems, and it's not that different. The challenges that they face are not that different from some of the challenges that we face in aviation. So we have a lot of commonality. We're all engineers in the end, and so we can have that good level of communications between the industries. And lastly, I think my message is that spectrum should become part of our DNA. And I strongly believe, this is not to challenge any of the work that ICAO, FSMP, or the ITU World Radio Conference do, don't get me wrong. But I think if spectrum should become part of our DNA, we should discuss it at more levels than just there. It shouldn't go, all the way up and then down on the other side. We should have those discussions, at many more levels. And here I think there's a key role for RTCA and for EUROK. EUROK Working Group 124 and RTCA SC 242, I think have gathered the best experts that we have in our aviation industry on spectrum, and I think that we should be very careful that we maintain that. So again, going back to, once we solve the 5G case, that's not going to be the end of the story. We need to make sure that we maintain our expertise, that we continue to support these working groups. And these working groups may actually help us to have those discussions at all levels, including providing support to the FSMP, but also, like Steve was discussing already or alluding to, many of the members of that working group are actually supporting the discussions in the CPT as well. Again, I really appreciate the work that they do, and I thank them very much for that. And I hope that, in the end, spectrum will indeed become part of our DNA whenever we start thinking about new systems, but also updates to current CNS infrastructure. Thank you very much.
Thank you, Hedy. Listening to you and to Steve, I had to chuckle when I said that Sandra's situation was complex, because honestly, I always forget that the European construct for governance makes almost any other region look reasonably benign. So I'm kind of laughing, but I'm kind of joking about it. But in reality, it is a really complex challenge. So we have two core questions that we were going to address. One is, what are the recent developments inspiring innovation in our processes, regulatory processes? And what can spectrum stakeholders expect in the future? And what I was struck by was the level of detail that Shunichi was able to present to us about the specific issue of how 5G has been managed in the Tokyo area with the charts that he provided. A layperson can go look at that and go, okay, I see what I would want to do. My question is, how does that get infiltrated through the community to where it becomes part of a data set that a policy regulator is able to take action on? So I'm interested in a little bit of a discussion around how you take all the different pieces of information and then discover you've got a problem, go to do the research, and then make sure that that research is peer reviewed and checked and available for the policy work. Shunichi, because you gave us that presentation, I'd like to ask you if you want to kick off.
Yes, in our situation, a little bit complicated because the launch of the 5G service is much earlier than other nations. It's almost two years earlier compared with the US. So we carried out something like a fundamental interference analysis based on the previous document, such as ITR M2059 or something like that. But afterwards, the RTC and EUROCAE carried out the a huge measurement campaign, and based on that, they carried out some standards. They carried out specify some the interference conditions. But before the RTC and EUROCAE published the document, we already determined the harmonization conditions. That is a very difficult condition for us because the at that time of the in our countries determine the mitigation measures set up, but currently our mitigation is, we think it's not enough to protect the array, so that in the first stage we have to summarize the every information we need for the interference analysis. So that we need to collaborate in a huge community, in a large community in future, not for the 5G, but for the future communication systems.
Okay, thank you. And we've had an audience question, which is asking, what are the 5G base station power, the EIRP power that operates close to the airports in Japan? Do you know what those are with the 200 megahertz and 100 megahertz guard bands to the 4.2 to 4.4 gigahertz band?
Just one moment, please.
Maybe we can come back to that if you want to think about it.
Yeah.
So I'd like to ask the others if they'd like to chime in on what their views might be on this question. Sandra?
Sure, thanks, Steve. And I really appreciate the comments from Sunichi and Hedy talking about RTCA Special Committee 242 that's joint with EuroK Working Group 124. And when I look at innovation for the future, I really like what this group is focused on. So I want to just take a quick second for folks that aren't familiar with. This is an opportunity to ensure that the radio frequency characteristics for aviation systems are specified in kind of a consistent and complete manner. And they are developing guidance for the RF parameters for the transmitters and the receivers that will include information like performance requirements, out-of-band emissions, spectral efficiencies. And what's envisioned is that this information will be put together in a reference document for regulators, but also given to radio system designers. And so I see that ICAO, ITU, as well as other organizations will use this information to help inform them for future studies where they're proposing new uses of the spectrum, and they can use this information about the characteristics of aeronautical systems to determine if compatibility is possible and under what criteria. So I think that's a huge development in our community, and I really encourage participation in that effort. The other item that I want to talk about is a discussion on receiver performance requirements. We've been having this discussion in the US, spurred by comments from the FCC of opportunities to, industry would like to come closer to aviation spectrum, but how do they do that without certain receiver specifications, as well, not just aviation, other spectrum bands. And so we're having the discussion of how do we create receiver performance requirements, out of band rejection. And so I think that that's another interesting topic that I think that can advance our community, the spectrum scenario globally, but definitely help improve in the aviation sector.
Okay, thank you, Sandra. And Hete, I'm going to ask you the question. I guess the challenge that I'm hearing from a safety regulator perspective is, how can we define new methods to truly test the edge of performance that will satisfy a safety regulator in a manner that can be validated for global adoption? Because that ultimately is required kind of on the front end before we can go make a case for an amendment to spectrum utilization across the board that might accommodate a new industry, or make the case even for aviation to move into a different place in spectrum if that was required by a future application.
Yeah, that's indeed a very good question. I don't know that I have the immediate answer. I think what I refer back to is, as Sandra did, that Special Committee 242, Working Group 124. I think that should become our pool of expertise, of aviation expertise in this field. So when a new entrant, a new use case arrives, I think that we may have to turn to them and make sure that they develop the methods to assure us as safety regulators that the use of that spectrum for that particular purpose is safe. and that we can build standards for that use case that we can then adopt in our regulatory system and be assured that safety is guaranteed. I'd also like to perhaps come back to your organization, Steve. I think what we also need to do is, we have a lot of expertise in the US and Canada and Europe, and a lot of those people are on the call right now, if they're not in Paris, working on the radial altimeters as we speak. But there is also a huge community out there that may not have that same expertise. And I think reaching out to them, giving them guidance as to how they should implement, these new spectrum criteria, spectrum related criteria, receiver, standards. I think that we should have a discussion in ICAO as well as to how we can do that better, so that they also benefit from what we're doing in these two working groups, and with all the experience that we gain in discussions with CPT and other organizations.
Okay, thank you. That's inspiring for me to know that there's a place for ICAO in the process that could actually be amplified and strengthened. But I think it needs to also, as you've said, take advantage of the technical specifications and the working group knowledge that's available in the RTCA and EUROCAE committees. Steve, for you, the question I want to just sum up with is, what can we all do as an aviation community to strengthen our hand to make sure that when we say we have an issue, when we say there's a problem, when we say we've done research, we've got the credibility that we need to have when we come to the global marketplace for spectrum?
Yeah, I think it's partly about having that conversation early and having that engagement with the regulators. So whether it's the national regulators like you have in the US and Canada, or whether it's individual national regulators in Europe or through the CEPT process, it can sometimes seem like many organizations a bit cumbersome to outsiders, but we try and be as open as we can. So, for example, we don't have password protection on our documents. They're up there on the website so that anyone can look at, and we try and be responsive as well. So when people started raising this issue, we acted to create a specific work. We had to reach out to the aviation industry, and there was we didn't immediately have the ideal contacts, so there was a bit of a time lag between starting things off and actually getting that engagement. But I think we're now at a good place in terms of getting that engagement. It is about talking to each other, I think, ultimately, and the more we do that, and the more we maintain those contacts. And we recently, EUROCAE, I think it was, or has organized a letter of understanding with ECC. So this is a kind of effectively an agreement to work cooperatively to keep each other informed. And I think these sort of partnerships will go a long way to making sure that we can spot things as they're on the horizon. Thank you.
Thank you, Steve. That's a great example. And for the engineers in the room, Dr. Udasamari has told us that the max EIRP is 60.8 dBm megahertz by the regulation, and 55 is typical power. So nobody is pushing the limits at this point. It's not dependent. There isn't a restriction beyond that that's impacting the installations on the ground right now. But you know what? I think that there's so much more to talk about. I'm so thankful that RTCA has set up this opportunity for us to have this engagement between the aviation spectrum community and the rest of the spectrum space. And I want to thank all of our speakers today for their engagement in this particular panel. And Terry, I'll pass it back over to you with the thanks from all of us, and to all of the presenters. Thank you for all the work you did to prepare us for this. Terry, over to you.
Thanks, Steve. I've been involved with Spectrum now for about 3 years, ever since we put out our report on potential 5G interference back in 2019. And I continue to learn, and this is another panel where I learned so much. And by the way, those statements you made were not provocative to me at all. I've come to some of those same conclusions. So thanks for validating some of the things I've concluded as well. Steve, Sandra, Dr. Futatsu-Sumori, Steve, Hetty, thank you so much. Great panel. We could have gone on this one for a long time. Unfortunately, we have another panel coming up, but I do appreciate both the time that you took to participate, preparation. So thank you very much for sharing your perspectives this morning and this afternoon. Thank you.
Thanks, everybody.
I just want to give a short reminder that today's live stream broadcast is going to be available for viewing on the EventMobi platform later today. You can just go to the platform and click on the main stage day 1 tab. That content will be available for viewing until December 21st. And then in January, we're going to move it all over to our YouTube channel, and we'll make sure we notify everyone when it's posted. And also, if you'd like any copy of the slides from today's sessions, just email us at membership@rtc.org. One of the many strengths both RTCA and EuroK have is the willingness to collaborate and work with others in the industry. And with our collective work in Spectrum, this includes those tangential industries that are outside of our normal working relationships. I'm going to ask Anna to join me as she has a special announcement regarding one of those partnerships. Anna, are you there?
Thank you, Terry. In fact, Steve has just taken it away from me. Steve, thank you very much, Steve Green. So indeed, we've done some major outreach activities in the last couple of years. RTCA has done the same. But here in Europe, CEPT ECC is definitely a focal point for information on Spectrum use. Steve has very eloquently described its role and main activities in this last session, which was indeed a very, very interesting and very informative one. But yes, so I'm very pleased to announce the signature of a letter of understanding between EuroK and the ECC CPT that just occurred last week. So it's kind of hot off the press, if you wish. So this letter of understanding will provide a basis, a framework for exchanging information and for cross participation between working groups. And really the first action here was indeed to provide a copy of the draft guidance ED 310 DO 399 for review during the open consultation and FRAC to the partners, and the comments here will be very valuable in the further development of this document. Outreach is really important to facilitate these discussions. I think we've heard that in both of these panels that we've had so far, and it's in our very nature to do so. So I wanted to take this opportunity of the summit that we're having this week to thank the CPT ECC, Steve for his participation, Chris Wolford as the ECC chairman, and all the involved colleagues both here in EuroK and RTCA and in the CPT ECC for the cooperation initiative, and we look forward to some great exchanges with our respective working groups and committees. So thank you very much for this.
Thanks, Anna. Great partnership as usual.
Indeed.
I did just want to remind everybody again that if you want to submit a question, just click on that Q&A section of the main stage day 1 tab. And if we don't get to all the answers, we'll get the answers and post them to our website in the coming weeks. We'll get started now on the next panel. Historically, it's been mentioned today several times, I think, aviation systems are really planned for a 20 to 30 year, even longer life cycle when we talk about both commercial aviation and military platforms, as well as general aviation. But with the rapid evolution of changes in both technology and developmental tools, we're really looking at shorter life cycles. Even for those avionics and systems that provide some safety critical functionality. And some of the new aircraft use cases, such as UAS and AAM, are going to be taking advantage of these capabilities with the goal of bringing some of those life cycles down to less than 5 years. So to discuss some of these technologies that are making all of this possible, we have a great set of panelists for you, moderated by Mr. Brandon Suarez from Reliable Robotics. Brandon leads the development of technical standards and global aviation policy for Reliable. He's focused on airspace integration and international operational approvals, and he supports product strategy plans and future aircraft programs. Brandon's deeply involved in the aviation community. He's an advisor to ICAO. He's co-chair of Special Committee 228 at RTCA, and he chairs the Aerospace Industry Association's Emerging Technology Committee. He's also active in several NASA research activities seeking to advance future aviation concepts, and is an instrument-rated commercial pilot as well. So, Brandon, over to you. Got a great panel. I'm anxious to hear what they have to say.
Awesome. Thank you, Terry, for the introduction, and thank you to RTCA and Eurocave for hosting this important two-day event. I was able to dial in earlier, and I've personally learned a lot, and I found it just really insightful and helpful as we figure out how to move forward. I mean, we're all aware of some of the contemporary issues. You know, a lot of discussion today about the 5G impact on C-band radar altimeters. And it's only going to get worse, as we've heard, in terms of both the spectrum congestion issues and the economic competition that's coming for aviation. So the panel today, I'm really excited, having gotten to sort of handpick the folks today. I'm excited for this. We're here to talk about how to use adaptation, how to shorten aviation product development life cycles. I think we've all benefited from the use of consumer electronics, both in general aviation. In my case, you know, I love flying with an iPad on my flight deck, and in the case of new entrants, right? Like we said, that are trying to bring life cycles down to the matter of years and months rather than decades. So we're very fortunate today to have really a great panel. I'll just provide a quick sort of one sentence intro and then direct the audience to the platform to get a longer bio and learn more about what these folks are up to. So first of all, we have Dr. Jim Davis representing UAvionics. UAvionics is a company that's dramatically shortening the life cycle of certified avionics products using modern processes and technologies. We've got Mr. Jesse Turner, who represents Boeing, and is the co-chair of RTCA Special Committee 186, and so he's well aware of the length of aviation and avionics development timelines, having led the ADS-B effort for a long time, as well as, you know, Boeing, where they're planning for aircraft to be in service for 40 plus years. We've also had Bruce DeClean representing the FAA. Bruce has had a number of roles and responsibilities at the FAA over the decades, and is now involved in regulating new technology and bringing together really the complexity both of the airworthiness certification process and the operational approval process through flight standards. We also have David Solar from EASA, who's responsible for general aviation and advanced air mobility. And so he's really on the forefront of rolling out new technologies and new capabilities in Europe. So again, I want to encourage the audience to enter your questions into the system. And we're really hoping, all of us on this panel today are really hoping to have a dialogue and a conversation. So please put your questions in. So while you're doing that, in order to sort of bring each of the panelists into the discussion, I'll just start off with a question and give them a chance to unspool a little bit. And so I'll start with Bruce. So Bruce, to get us started, could you just give us some thoughts on the FAA's efforts to accelerate new technology development and deployment in the NAS?
Yeah, absolutely. Thanks, Brandon, and a pleasure to join you this morning and have hopefully a good discussion. You know, as you noted, I have a long career in the FAA, largely working avionics and regulation, and I want to kind of emphasize, you know, we have the part of the responsibility for safety and interoperability as it's relevant, not the spectrum allocation, which is kind of its own regulatory topic. So, but just kind of thinking about safety and interoperability, you know, we have made a concerted effort as we develop rules and requirements to migrate to performance-based requirements. And what's important about performance-based rules is they have kind of a built-in agility, so that as long as the desired performance can be achieved, the means of compliance can evolve. And that is true in the radio and technical space as well, and hopefully provides basically change-ready rules as technology comes along. We also depend very much on the use of voluntary consensus standards. So, you know, we don't expect in aviation that we really have the resident expertise for every new technology and innovation. We work together with industry in that area and ask industry, how can you step forward and develop industry consensus standards? So when you think about the life cycle and how long it takes to adopt new technologies, a key component of that is how long does it take industry to develop a standard to use for that new technology? In the meantime, before those standards are developed, one thing that you see us doing a lot in our current projects is taking full use of our agility in project-specific criteria and methods. So we had recently published for comment a proposed criteria for Joby aircraft as an example, AAM, the first of the AAM aircraft that made application in the United States. And that criteria is specific to that project. And we'll be publishing more criteria for additional projects. So we have a lot of flexibility in the US system to tailor what we're doing to specific projects in the immediate term while those performance-based rules and voluntary consensus standards are developed. And that's really how we handle safety. I wanted to just take a minute to kind of tee up for discussion interoperability and the role of interoperability. You know, in a lot of the spectrum utilization in aviation, there is an industry standard that is invoked by us, let's say through a technical standard order, that specifies very detailed technical criteria of signal design, and that is necessary in some cases for interoperability. TCAS is a great example I would highlight. You know, we depend on TCAS as a safety enhancement to reduce the risk of collision between aircraft. That only works when the radios in those aircraft are able to talk to each other effectively, and they are constrained by that standard. So in that case, again, the pacing item from the regulatory standpoint tends to be the development of the new standards. Once the standard is developed, then it largely is a market question, and I'm sure we'll have a lot of good discussion about that. So those are some initial discussions, and I'll turn it over back to you, Brandon, for another question. Great.
Yeah, no, that definitely gets us rolling. I'm getting a few more questions from that. So thanks, Bruce. David, next to you, I'm really curious as a general aviation pilot myself. I'm curious how you think technology that's being used in general aviation can, especially when it comes to RF spectrum, can be leveraged for new entrants like urban air mobility and regional air mobility and small UAS.
Yeah, that's a very interesting question. Thank you, and good morning or good afternoon, everybody. I would split, the question in two, and I guess for non-commercial operations, non-air taxi, I would say that would be there. I think we could leverage all the GA technology that is around, which is fully applicable, fully aligned. They will use the same airspace, the same kind of usage. So I do think this part of the business will be fully adopted the GA technologies that are developed today. Now, on the other side of the coin, I think we have the extreme usage for commercial operations, and we all know that if we look at urban air mobility or advanced air mobility, whatever we call it, in the future, it's a large operation at scale, more like airliners, if we like, even though the shorter flights, but much more numerous than GA. I'm not sure some GA solution as of today would fit for several reasons. The first one would be, these operations would be extremely data hungry. They will need data on the machine, machine-to-machine interfaces, machine-to-machine exchange of informations. On the communication side, with whatever it will be, we have a use space definition in Europe, for instance, and weather also probably, some of them will not be able to fly in icing conditions, so we'll have to forecast quite accurately the weather, and weather stations will be all around the places. Site availabilities, whether they are contingency site on locations if you have an issue, health monitoring, vertiport data, passenger data, and also something which is probably new, which is I call it multimodal data of transportations. I do think all these vehicles and the business case will be useful if we are able to connect to other means of transportations, and in a seamless way via platforms that are today in development. And it means integrating with trains, with airports data, with local city train, maybe taxis also, ground taxi, and all of that is really a challenge by the volume, but also by the fact that it's non-aviation kind of communications and spectrum. So we'll have obviously to make our ways and to adopt also non-aviation protected spectrum bands and to work with that. The second aspect also for this specific operation is the availability of services. We will have to have a guaranteed availability of services in some instances for some of the applications which are safety related. And so far, yes, there is aviation spectrum. There are also some other capabilities, and like 5G, you can have some reliability of services that are embedded into that, and we need to share with the whole community and obviously the whole bandwidth. And on the third point is these vehicles will operate into airspace that are today under definitions, and at least in Europe it will be a use space, and we have the first regulation that came out. And within that, we have a e-conspicuity mandate. So every use space user will have to be e-conspicuous, and it includes not only urban air mobility, but also UAS and any users that will enter into this airspace. And that's a game changer also. At least, I know that in the US, there is an ADS-B mandate for almost everybody, but not in Europe. So it will change a bit the game. Obviously, to do that and to introduce all these novelties, we'll need to be aligned. Both on the aviation side and non-aviation side. That's one of the points we need to open up a bit more. And you mentioned it, speed up the adoptions of some technologies. And for that, I hope we'll take the problems not upside down. Sometimes we did in the past, if I take a data link, for instance, almost each case was then leading to a standard, and we are ending up now, I think, with 15 standards around the place. Rather than having a more okay, what are the end user needs, and develop a standard that is fitting everybody. And that's really the goal. And to develop these standards, we have some regulations that will probably go hand in hand, and in parallel we need, as Bruce mentioned, the industry standards. And instead of waiting for the regulations, we need to work in parallel. That's what we are trying to do. For instance, in the ACAS XA development in Europe, we have currently NPA, Notice of Proposed Amendment, on the regulation, which is ongoing. And in parallel, we are working on the standards. It's a bit more risky approach because you have to, at some point they should be aligned. But I think it's the only way to reduce the life cycle and shortening how we introduce these kind of things. And lastly, on the 5G story all over the place showed that industry and aviation industry can react fast. So that's a good sign. Now, when you look at the amount of resources we had to involve into this issue and solve it, may not be commensurate to the exact risk. So that's something we need to find and fine tune, obviously. But really, at least on the other side, we are committed to work hand in hand with industry and other stakeholders beyond the aviation ones to make sure it's going to happen and introduced in a safe manner. Great.
Yeah, thanks for those thoughts, David. Jesse, turning next to you, you have a ton of experience. You've been in the ADSB world probably since the beginning. And I'm just curious if you might walk us through some of the things that the community, that especially new entrants, but as we move forward with all of aviation, trying to adapt faster, what are some things that our community can learn from some recent examples of these global technology rollouts like ADSB?
Yeah, ADSB, of course, was a pretty significant effort worldwide. It wasn't just a regional thing. And so it obviously took a number of years to go from start to finish. And like any significant new technology introduction, there are lots of variables, lots of risks that we have to account for in each phase, all the way from requirements development, industry standards development, as well as the detailed design, testing, all the certification activities, and then of course finally with the implementation. And each one of those has its own risks, lots of variables going on. And so one of the lessons learned is when you think that you're going to do it in a certain amount of time, believe me, it's going to take a lot longer. And I think everyone smiling on the video has gone through this, right? You have a plan, and of course, over the course of time, that plan adjusts to the realities as we go along. And so we have to be flexible as an industry to account for those unforeseen things that come up. But as far as some of the lessons learned, as Bruce alluded to, industry standards and interoperability is key. They're vital to our industry. I'm speaking from an air transport perspective, of course. Everything that we do relies significantly on those industry standards. So getting everyone to the table, I think in the case of ADSB, it was quite a success because we had, of course, all the industry participants, whether they be avionics, developers, manufacturers, the airframers. But probably more importantly, we had a number of regulators worldwide that were involved in that industry development. And when you have that, and also want to mention in the case of ADSB, air navigation service providers, basically their air traffic control arm. So when you have everyone worldwide involved in that, you can actually come to consensus on requirements that early. That is very much key to actually having a successful implementation. In the case of Boeing and airframers, of course, and operators as well, everything's operated worldwide. So it's very important to have that interoperability. And so developing those key standards in the performance requirements early with everyone involved at the table, I think was key. And even once we got to the point where we actually had the standards produced, and we had the regulatory material, the advisory circulars and TSOs supporting those, there was still a lot of coordination that had to occur. And I want to give credit to a lot of regulators and industry groups that supported ADSB, because those were key forms that people, even though the standards were produced, to get people together and even educate folks. Example is Equip 2020 in the case of the FAA. I think a huge success because they brought folks together because yes, the standards are out there, but there are always implementation questions, and there are always topics and key issues that are developed as you're going through the development and the certification. So, in the case of the United States, FAA with Equip 2020 was a success. In Europe, Eurocontrol held surveillance forums as well, and for the implementation over there. ICAO Asia Pacific regional office held annual meetings with all the key stakeholders, including regulators and air navigation service providers in Asia, again, to come up with planning as well, execution, and also what are some of the issues that are coming up. So having that forum and worldwide forums were very key. And probably lastly, having as far as air transport is concerned, and the speed at which we develop and field things, there's one thing about being able to develop the actual standards and actually design the equipment and come up with it. It's quite another to actually get it implemented. In the case of ADS-B, we're talking thousands of airplanes worldwide. And aircraft fly in the air transport world. It's a different group than consumer electronics, of course. I mean, aircraft operate 20 hours a day. There are very few times where you have enough time to actually, the airplane is down and you're able to take advantage of that. A checks, which are only a day long, doesn't provide sufficient time. So B checks, which account 18 months to 2 years, is really the only time when an aircraft is down. Otherwise, to pull an aircraft out of service to implement some of these technologies, that's a huge impact on operators. And kind of the story with getting any new technology on an air transport airplane, it's either you have to, it either has to be mandated or it really has to buy its way on the aircraft. And so in the case of aircraft or changes that aren't mandated, the return on investment has to be very short, and the operational capabilities and the benefits that the airlines realize out of that technology need to be very relevant. And so it's a different paradigm, of course, than the consumer electronics. And so we taking that into account, we in terms of implementation, we have implemented things like software data load. The later aircraft have that capability, networks, so that you don't have wiring changes. So we have done things in the air transport world to be more expeditious in implementing new technologies, and so we'll just continue to do those.
Awesome. Good, Jesse. No, thanks. That's a lot of good wisdom, a lot of nuggets there to unpack. Jim, lastly, I wanted you to go last just because I thought you might have some things to respond to from the previous panelists. But what I really want to ask you is, what are some things that your company is doing differently from maybe some of the legacy aviation developers to deploy certified products quicker?
Yes. Well, first of all, I'll begin by saying that many of Jesse's comments regarding air transport certainly migrate down into general aviation. We have the same hurdles coming up with standards and getting them turned into TSO products that make the airspace safe. And in fact, Avionics vows that it was founded basically to keep the level of airspace safety high, despite the introduction of things like unmanned air systems, those sorts of things. Anyway, what we may or may not do differently than some or all of the legacy people, we look at the life cycle of products and we attack the front end. We recognize that things are changing faster than they have in the past, and certified products are needed perhaps more quickly than in the past. And one way to make that more palatable to users is to decrease the cost. If you've bought a product and installed it and the overall cost isn't that great, you're much more likely, when the technology changes or the rules change demanding new products, you're much more willing to swap it out for something new and better. So to that end, we sort of approached it, we've used a two-prong approach. One is to make equipment smaller. In fact, we're probably best known for making very, very small miniature products. We make, for example, both certified and uncertified transponders with ADS-B out. We have a certified Mode S transponder with ADS-B out. It's class 1, which means it's high power. It's level 2. It weighs 50 grams. It weighs hardly anything. You can hold it in the palm of your hand, not even really notice it. We make a GPS that's very small, combined antenna and receiver that weighs 20 grams. It's about the size of a silver dollar, but a little bit thicker. And these are primarily aimed at the small UAV market, which we see as a growing market. The key to getting those certified, well, first of all, the key to keeping it cheap, and which you want to finish the product before you certify it, is you want to take advantage of new processes. Many of those processes depend on very sophisticated modeling and simulation software. And by using that knowledgeably, you can reduce the iterations required to get to a final product. And if you reduce the number of iterations, you've reduced the upfront costs that have to be recovered, and the product can be less expensive. And if it's well designed, then potentially you can ease the installation costs, which can be a large contributor to the overall life cycle cost of the product. So we do all that, and oftentimes we do it in close cooperation with the FAA, who in the civil world has to ultimately certify it. For example, our GPS, we actually started with a commercial GPS core. We didn't develop it from scratch, but the all-important integrity software that generally goes with an aviation GPS, that we did. We basically started with some very reliable hardware and surrounded it with very reliable, in this case, it was design assurance level C software. And the result was something that ultimately earned a TSO C145 Echo class Beta 1 certification. So that's a little bit different than what I understand many of the legacy suppliers of GPS have done. And this unit, TSO product, sells for less than $1,000, which astounded me, because I actually started out in avionics in the GPS world, actually back when Bruce, who spoke earlier, was sort of the FAA guy on the RTCA committee working that problem. And it's, well, I'll get into another aspect. As I mentioned before, one of the costs of a new product and adapting a new product to a new environment in the airspace is the installation cost. It's not unusual to buy a piece of equipment, but the cost of installing it into the panel can exceed the actual cost of the equipment itself. And that drives pilots crazy. We actually found a way, and this was partly working with our FAA people to make sure everything was kosher. I would call it creative installation, where instead of installation taking hours, days, whatever, you could actually do it in under an hour. We actually have products, many of the people listening to this probably may even own them, where we recognized that airspace requirements were changing. ADS-B was being developed and was being mandated, in fact. And there was hesitancy on the part of many pilots to adopt it. They didn't want to spend the money. What we did was we came up with low-cost products through modeling and simulation and having good people working the problem. But we also came up with an installation scheme that didn't cost a lot of money. And in fact, I have some, if we can show a slide as an example, yeah, that'll be fine. This is a sky beacon that we did. The key thing here is because we were also catering to the unmanned air vehicle market, especially the small unmanned air vehicle market, we added very small, very lightweight components that you would need for an ADS-B system. So what we did was, most airplanes, many general aviation airplanes have a light on the end of the wingtip. So, and that wingtip has 2 power leads running to it. So we would remove the light and we would replace it with this picture you can see, what we call sky beacon in this case. And that contains a 978 megahertz UAT transmitter for ADS-B out. But ADS-B also needs a GPS. Well, we have a 20-gram GPS that's TSO, so we stuck that in there. We put in an antenna that had sufficient coverage to give you the antenna pattern that you need. But wait a second, we removed the wingtip light. Well, we also put in a wingtip light that we had to TSO, and the result is what you see. Now, you may be thinking, if you're familiar with ADS-B, well, what about squawk code? You can't really pre-program the squawk code because it might change during flight. Well, it turns out that electronics, avionics aren't perfect, neither is the power system on an airplane. And when you transmit a squawk code from the transponder, which is already there, remember, we're only introducing ADS-B, we're not replacing the transponder already on the aircraft. When that transponder transmits the squawk code, it's a high power that causes dips in the power supply. And we actually have a code reader built into the Sky Beacon product that looks at the power going to the wingtip light and looks at the dips and knows what the squawk code is effectively. And then it puts that into the ADS-B, and you now have an ADS-B out system, and you really haven't had to touch the panel. All you've had to do is remove a wingtip light, hook up the power leads to Sky Beacon, screw it all down, and off you go. So I think that's
thanks.
That's a little bit different.
Yeah, and a good example of adaptation. You know, I think there were probably 3 or 4 examples there of adapting to a use case that is very different from what had come before it.
Yes, so
it makes a lot of sense. We've had a few questions come in from the audience, so I just want to make sure we get a few minutes to address some of those. Kind of have to toss all my questions to the side here, but there was a good question about, you know, Bruce, earlier you mentioned performance-based regulations, and Jesse, you talked about having to equip, you know, thousands of aircraft worldwide with ADS-B. And I'm curious, someone in the audience is curious how we overcome this regulatory approach in aviation where we tend to cater towards the lowest performing aircraft or the sort of minimum use case, almost to the detriment of everyone else, or at least the advancement of a particular technology.
I'll jump in first. I think, you know, we work hard with industry to make sure that the minimum standards don't limit the maximum capabilities. So sort of individual solutions can overperform, and there's no requirement against that. I think the way I take the spirit of the question is, it is interesting. You know, there always is a minimum. There always is some market solution that just barely meets the requirements. I think if the conversation is the minimum in the right place, that goes right back to the industry consensus body that's developing the standard, which we sort of challenge them to have that as a robust debate and hopefully arrive at a consensus outcome. On the rulemaking side, if it does involve something that we have to impose, we go through a fairly disciplined rulemaking process, which includes consideration of alternatives and costs, et cetera. But so I think the spirit of the question really isn't about enabling the maximum, which you can already do. It's really, where is the minimum, and is it drawn in the right place?
Yeah, and add on what Bruce said. I mean, I totally agree. I mean, anyone that's been involved with standards development committees, you can argue for half a day over just one requirement on performance requirements, and it's consensus based, and you listen to everyone's inputs, and at the end of the day, though, it's made clear that the outlier does not dictate what the end requirement will be based on our experience. You don't over design to it, but as Bruce said, there is a minimum performance level that's specified. And but outliers that are underneath what's considered state of the art at the time, those really are thrown out, because as long as the consensus is that you can meet a particular performance level, that's what you're going to go with.
I would only add that the committees go through an extremely large amount of creation of documents about how the equipment is used. They come up with standards. People agree with the standards, or there are non-concurs, then there are reviews, and the non-concurs, a great deal of effort goes into finding the happy medium. A lot of work goes into that. And people still make better equipment. They may charge more for it, or they may do something different. That's the way the market works. Some people will buy it. Some acceptance pilots demand that. Others won't. And as long as the minimum is set right, as Bruce pointed out, you maintain the airspace safety.
Another question from the audience. So obviously our panel today had the term adaptation in it. So just curious on your thoughts, given everything that's been said, what are some practical ways that we can build flexibility into avionics and RF systems and regulations going forward?
Software defined. Oh, sorry, go ahead.
No, go ahead, Jim. I think you were going to say pretty much what I was going to say.
I mean, software-defined radios is sort of the poster child for all this, where, for example, there's now ongoing development of a C-band command and control radio for UAVs that have been set aside by the World Radio Congress and every ITU for use for command and control of UAVs. And it's over a range of, I think it's 5030 to 5091 megahertz. And you'd like a single radio that could sort of pick out a center frequency, whatever's assigned to it, and do it. And those software-defined radios work these days. You don't have to have individual, an analog switch to switch between inductors and capacitors to get the right frequency. And that's adaptability. Couldn't have done that a few decades ago, but today it's sort of the most logical thing to do.
Yeah, and along with that, on the implementation side of that, when you look at earlier generations of commercial aircraft, such as the 767, 4737, many of the radios were hardware based, on-wing software loadable. And as we've moved in time over to the latest aircraft, such as the 787, A350, et cetera, many more of those pieces of equipment are now on wing software loadable, which is huge when you take into account in terms of implementation. Being able to actually load something on wing. I mean, as an example, the ADS-B, when you compared how much time it takes to do an ADS-B retrofit on, say, a 767 compared to a 787. 767, you got to do interface wiring. You have program pin wiring right behind there. And then you have the hardware box swap. So you have to get a brand new piece of hardware installed. Versus the 787 network-based airplane, on wing, ADS-B implementation was on wing software loadable. Not only you didn't have any interface wiring to do because it's all already hooked up to the network. No program pin wiring because you have option selectable codes that are on board loadable. So as we've transgressed through the years to new airplane implementations, things have gotten a lot better on the implementation side as well.
If I can use a different example for a minute, the FAA promulgated new requirements for drones to have remote identification, the remote ID rule. And that's sort of a good intersection for today's conversation. We have both retrofit challenges because we require remote ID on all drones previously sold if operated in various parts of the country, and also a requirement on new drones. And what we did there is we embraced that performance-based strategy that I talked about earlier. So the performance requirements that we require are very general. They leverage commercial technology. So that's kind of another key element, is where you don't need unique aviation requirements, don't develop unique aviation requirements. So that rule actually requires the use of an FCC Part 15 radio, Bluetooth wireless, allows for an industry consensus standard that was worked in parallel to the rule, to get back to one of David's remarks and sort of the importance of shortening timeframes, and planned ahead for the kind of retrofit that Jim, you described, in terms of very small things that if you do have to retrofit and you don't have it in your small drone from before, how could I get a sticker? How could I get this thing down to the size of a sticker? And so I think that's a great example of kind of where we need to continue to chase those same strategies and migrate them up into larger aircraft.
Awesome. We're about out of time, so I just want to ask one more question real quick, and David, hopefully you can chime in. You mentioned, moving into spectrum that has historically not been open to aviation use, licensed spectrum, but not aviation protected spectrum. There's a question from the audience around this idea of the ability to potentially impose regulations or limitations or restrictions on other users in a band. They were using the 5G signals, maybe time of day or environmental sort of limitations that could be put on them. What are your thoughts on the ability for aviation to maybe impose good neighbor requirements on other users in a licensed band? I think you're on mute, David. Sorry.
Yes, I do not think imposing is the right way forward. We have to find a consensus, and that's something, yes, you mentioned reducing the power. Actually, that's what we did in Europe. There is a limitation of the antenna power. It's not in the contracts of the provider, so they cannot emit at any level they wish, or the max power, which is sometimes very high. It's all over putting the right people on the right table and understanding each other, what are the constraints, and I'm sure we can find solutions. If we are imposing anyway, if you compare the size of aviation industry compared to telecom industry, I'm not sure we will win the battle, to be transparent. So better we reach a good consensus, understanding in some spots. For instance, yes, it could be possible, and I'm sure it's going to be done. But really, that's something we have to not also live in our bubbles. We need to get outside and to recognize that things are moving on, not only in aviation but elsewhere. It's down also to be more aware of the technologies that are being developed for other applications that we could embrace also. There is a question on off the shelves. Yes, it's often, you know, the big temptations but when you get down to, okay, will it fit for purpose at minus 40 degrees and also at some altitudes, then you hit the spot and you have a problems. But we can do better for sure on that by anticipating more, definitely.
Good. Well, thank you. I want to thank all the panelists today for taking the time for preparing this and for being on today. And again, thank you, Terry, to RTCA and EUROK for hosting the conversation.
Great. Thanks, Bren. Appreciate you moderating the panel. Very interesting. I, again, keep learning all the time. Jim, Jesse, Bruce, David, thank you for your participation as well. Well, I think we had a really great set of panelists today, and I'm sure you all appreciated their insights and hopefully learned as much as I did. And so again, I want to thank all of our panelists for your time and participation today. Just a quick summary of the three panels that we saw today. Our first panel was on lessons learned. We heard about some of the regulatory challenges that the FAA has had in this space. We heard about the importance of collaboration across our industry, impact airports, and the importance of early engagement during the developmental phase rather than the implementation phase. Panel two talked about the changing regulatory environment. We learned about how frequency spectrum is managed here in the United States, some of the mitigation efforts in Japan, the role of CEPT in Europe, and the coexistence studies that they had done, and the importance of the use of data, which is something that's very important as we interact with other industries as well. And also heard about taking a more efficient management of our spectrum rather than the conventional approach that we have been historically doing. And then finally, in this last panel, shortening the avionics life cycle, learned about from the regulator the importance of safety and interoperability, how we can best leverage GA technology and data, the importance of forums to discuss planning and implementation plans, and some approaches that the new technology manufacturers are using to make things smaller and less expensive with some new processes in their design and development. So again, a great first day of the summit. I will add that if any of you are interested in joining the working groups or committees that are working on spectrum issues, you can visit the Documents tab and click on the Spectrum Compatibility Resources document to get in touch with our committees and working group leaders. Reminder about the survey, please don't forget to give us your feedback on this event. Very important as we continue to look for both other topics to bring forth to the aviation industry, but also how things we can improve as we do any future events such as this. Again, remind you that today's broadcast is going to be available on demand a little bit later today on the main stage day one tab. So you can click on that if you want to review any of the presentations for today. And again, I want to thank our sponsors for our event this week. Special thanks to the Airline Pilots Association and Garmin for their generous sponsorship so that we can bring you this Spectrum Summit to you this year. So we will pick this up again tomorrow, starting at 9:30 a.m. Eastern Time. That's 15:30 Central Eastern Time. We hope to see you all then. Thank you all for being here today and for making RTCA and EUROK a part of your day, your afternoon, or your evening. Thank you all.